All right, appears to be live. Thought the frame rate would be better, but it doesn't look like it is. So the changes I have made
appears to be live.
are not successful.
Thought the frame rate would be better, but it doesn't look like it is. So the changes I have.
So anyway, so maybe I just have to live rooms in some other manner, some other software. Yeah. Anyway, so I'll fix that some more in the future. Could try reducing the resolution some more, but yeah, what the hell? Give it a try. The hell. So I need this window and settings and bandwidth. Here we go. Just bandwidth. I'm gonna go down a little bit more. Go down very low. Yeah, see what very low does. Anyway. So yes, I just don't know what it does, in terms of increasing bandwidth or decreasing, frame rate increases versus quality decreases. They should just make that clear, but they don't, so it doesn't matter. Anyway, okay, I think it's, well, whatever. All right, moving along to the subject. Comment first starts, and then we'll get on to just the general subjects, and I'll just do my little overview thingy of some of the subjects and see if you see one that's missing or some point that needs to be made. You can let me know. If you have anything to add that's in some way relevant, I might be interested, depending on relevancy. All right, so the J, just another snark comment. Funny how you sit in your crappy house, totally irrelevant, criticizing real physicists. Okay, I'll concede they're real in the sense they have the formal education. I have the informal version of the education, and one that's not tested, on how well you understand mathematical equations, but I would frankly say I could win the test on recognizing where the math doesn't match the results, where the experiments aren't conclusive, and incredibly weak the evidence is. Done that research. Lots of things I would say are missing from the physicist, the real physicist education. And clearly the biggest thing missing is a consistently reasonable or rational model of function. Their Rube Goldberg machine is full of spooky action. To quote Einstein again, it's just sort of ironic. Einstein says things like spooky action at a distance when what he created was called, what it could be easily called spooky space. This spooky space, this bendable nothing. Just all crap. But anyway, you sit to criticize, draw out ideas. Well, drawing out ideas in the sense that talking about the fact that there's two parts to physics. There's describing effects, formalizing even with mathematics effects, and then understanding causes. Having some understanding that, in the case of the inductor and a wire, understanding that the wire conducts the magnetism and converts it into electricity, that it actually does. There's a force that actually hits the wire, and that force causes a change in the atoms, and the atoms end up transmitting pressure across the conductor, and that you can measure the pressure difference between the two ends of the wire. Now, understanding conceptually what's happening, in my opinion, is physics. Being able to do the math to say how many millimeters of wire can collect how much force, that's nice, but it's not physics. Without developing the maths model. So there must be an Englisher using the word maths, plural. Mathematical would be the correct word, in my opinion. Again, and I've said it 4 million times, I don't need to redo the inverse square law. I've already pointed out how I would redo Newton, in the sense that the idea of combining the two masses and creating one force is wrong, because both objects create a force. Both are active participants in their own way. The Earth moves the sun moves the Earth. Fact. And to call it one force, yes, the end result is going to be what will appear to be one force, because the only thing that's going to end up moving from your perspective is the Earth, because you're not going to see the movement in the sun, because the sun's 1,000,000 times bigger, and the movement's going to happen with its center of gravity. So, but the fact is, I've pointed out where there's errors that, in my opinion, are kind of obvious in what math exists. But most of the math, 85% of the math, is simple stuff like mass plus velocity equals force. Simple stuff. How many little bits are in it? How fast are the little bits moving? Oh yeah, that equals how much force or impact it'll have when it hits something. Yeah, no big surprise there. I'm not disputing that math. Anyway, language of physics, he calls it math. No, it's not the language of reason. The language of reason is English words, concepts. You make comparisons, you show consistencies, and you show inconsistencies. So like in the two-slit experiment, you people all focus on what looks like, this, oh, it's waves. And you don't pay any attention to where waves don't match, like the single slit. You just don't care that, oh yeah, it doesn't really work that way, does it? In the real world, waves don't do what light does in a single slit. But you just concentrate on the stuff that matches, and you just ignore the stuff that doesn't match. That's your way of doing the logic of deduction. And I'd say it's intellectually immature, that you don't understand. That's cheating. It's cheating the truth. And you do it all over the place. Like Einstein deciding just for photons will make all the gravitational bodies twice as massive, just for photons. And act like you know something they don't. Well, I'm not acting like it. I'm overtly stating it, that they don't understand, that they're wrong, that there isn't spooky space, there isn't bent to time dimensions, that there's no such thing as a warping a time dimension. There's just time dilation, which is time. It's basically metabolism retardation. And that the universe maybe isn't expanding. Maybe redshift is a symptom of space travel, that any little bit flying through the universe will encounter a certain amount of interactions through that process. And each one of those little interactions will have a probability, a higher probability of causing redshift than blue shift. Just a fact, just a reasonable explanation for the process. But, you don't care about reasonable alternative explanations because you're a religious kook. Plain and simple. A fanatic. Yet they build instrumentation, smash atoms. So again, just talk about it as if these aren't things that most scientists do by the same way the Wright brothers figured out how to fly an airplane, trial and error. And, that's the way it's done. Perspiration, very little inspiration. Create new elements, yes, that last a millisecond. I wouldn't say that's really a creation. If it dies in less than a second, it's not much of a creation. And develop the very ideas that we all have are built on, that all we have is built on. So more nonsense that somehow without quantum mechanics, the round wheel wouldn't be round. More just complete hyper exaggeration, just hyperbole, bullshit, propaganda. It's just simply propaganda. That without this strangled mathematics, that somehow we wouldn't have figured out anything, when, of course, we already discovered it before we even knew we had it, like lightning rod. Like, even Einstein again with the photoelectric effect. They already had the they already had the transistor right in their hands. Why don't you get a job, more irrelevancies, or a second or third job? It's more nonsense. Get some money, clean up your house. And how does it mean anything? And fix the ceiling. So why didn't Einstein comb his hair? So that's it, right? I can defeat Einstein just by saying he was too lazy to wear some decent clothes and zipper up and comb his hair. So therefore he's an asshole. Okay. We can throw him away. We don't need to pay any attention to anything he ever said. That's all you're doing here. It's just the cheapest form of argument. And you're too stupid to even understand how stupid an argument that is. So you want to talk about being a physicist, on what it takes to be a thinker. And you can't even think far enough to figure out that this ad hominem nonsense doesn't mean anything to an intelligent person. Absolutely meaningless. It only means something to the idiocracy. It only means something to an idiot. So you're just demonstrating that you're not really capable of engaging in the conversation because you can't figure out the simplest, you can't do the simplest reasoning skills. How can you understand what forms the inverse square law, or what causes it? When you can't even figure out that talking about this kind of trivial crap doesn't mean anything to a rational person. Maybe if you have maybe if you have some cash left over, you could go take classes at a local community college. So somehow the community college is better than watching Yale and MIT lectures. So just as a curiosity, that's his theory. He has a theory that if I go to a community college, somehow I'll get a better education than I could get by reading the books that are part of the college course. I can do that without going to the college. And I'm going to get better instruction than I would get from Yale and MIT professors. And Stanford. Let's not leave out Susskind. You're too silly to even figure this out. That if a person's motivated, they can find the information. They don't need some instructor to teach them how to. Well, now you open the book and you start reading the little lines of text. Yeah, I don't need somebody to do that for me. I don't need to pay somebody to teach me how to open a book or find an internet page. And you're too stupid to realize that simple truth, that it's much more efficient not to go to a community college. It's more, I'm wasting time driving and doing all that other stuff when I could be watching lectures. You might actually learn something. Well, you seem like you're probably a little bit below the educable level. Like you can't quite figure out, like I said, this simple stuff, that these meaningless arguments about my personal habits have no authority in the conversation to anybody with any intellectual honesty. Anybody with a little tiny shred of intellectual honesty knows that's a garbage argument, complete trash. You didn't say anything in there to make any statement whatsoever impugning any of the statements I have made or any of the arguments I have made. You haven't diminished them in any way by showing their weakness or how they're not well formed or in any way inappropriately presented. You did nothing. Okay, you accomplished nothing. So you're the one who needs to learn how to be a decent human being, an honest one, an honorable one, and one who understands just basic logic, that in a logical conversation, you have to make and form an argument that's relevant. Then that means it has to have something to do with, like when I bring up the fact that it's a gimmick to decide that photons are special and that all the bodies in the universe all of a sudden have twice as much mass because a photon is going by. That's a gimmick. And until you prove with some really good evidence, that's all it is, a gimmick. So anyway, as I often say, F you. Yeah. All right. Always looking at self. People in the community colleges are trying to change themselves. That means people in Yale and Harvard are trying to change the world. Well, that just sounds like absolute crap. But whatever. I think that sounds like nonsense. I don't think you can make such generalizations. I would just clearly argue that the professor being paid $300,000 a year or more is probably a little bit more skilled than the guy getting paid $60,000 a year. That's all, asshole. Oh, shit. Oh, God. It's true. It's irrelevant. So you really think that a college that has 20, 30, 40 times the resources, the money, the hardware, gets government contracts to do all kinds of fancy projects, build satellites, you really think that that institution is less equipped to provide educational fodder than a community college that has no such contracts, isn't doing anything interesting, and is probably reading out of 1943 books? Then you're an idiot. Do you have any friends? Well, you're not obviously on the list, and you're now blocked because you can just go fuck yourself. This is just tripe. Irrelevant, insanely irrelevant. So fuck off. Goodbye. I mean, time waster. I have a community college theory. It's really important. No, I bet it isn't. Oh, God, pathetic shit for brains everywhere. All right. So I did make myself a list because I'm, preparing to do some writing, and I was thinking of doing the writing in, kind of a form where I'll make a statement, do some description, and then make a video on each one of the subjects individually. Something like that anyway, in my head, I'm thinking. Because some of it needs illustration, some of it needs, you have to really talk about it a little bit for people to get the idea. When I say something like there's little bits in the universe, there's two kinds, plus and minus, red and black, whatever. And there's two kinds of matter bits, and they're not getting, even though it's a simple description, they need the illustrations apparently. But anyway, all right, so the first thing I wrote down was bent space-time. And again, it doesn't really have anything to do with the bending. We know it's a convergence. So it's stuff, and by their description, it's a convergence that is a pulling, not a pushing. So it's an anti-divergence, as Susskind would call it. Yeah. So it's all that stuff is coming from the outside and going to this little point. Coming from the outside, going to the little point. So it's all a big sucking sound. And there's no blower on the outside. There's just a pulling on the inside. And clearly that doesn't make much sense. That the simpler answer would be to have pressure on the outside that pushes things together, because push is just such an easier force to imagine to manifest as a physical reality. A pull is complicated, and like I said, in most cases where you think something is pulling, I can describe for you why it's a push. Okay, it's obviously a push. Even when you breathe in, it's the air pressure on the outside that makes that possible, not the fact that you're actually pulling something in. So anyway, so what is bent space? Again, it's just spooky space, we could call it, right? I could give it a new name, so I'll write that down. Spooky space. Because it just does this spooky thing. Somehow the space just converges, and somehow it drags the planets with it. And that's exactly what Einstein's argument is, exactly how it's described by Susskind, Leonard Susskind, when he does his detailed analysis of Einstein's field theory. That's what it's described as, essentially. It's a fluid. The stuff is floating in, and you're pulling on the fluid, and it's dragging everything with it. And that's all it is. That's an explanation. That's all they have is an explanation. So they have no mechanism, no force. They have no physical energy. No, nothing's, the sun doesn't use up any energy. The earth doesn't use up any energy. No energy is consumed by this movement. So there's no source for this thing. And then you have this alternative model that clearly has a source, in the sense the external pressure is just created by a bunch of noise, a bunch of background radiation. We have examples of background radiation. We know of its existence, and that's what's doing the work. Clearly a perfectly rational explanation, perfectly mechanical, sensible, and yet the physics and its little sycophant followers refuse to even think about it. They refuse to even talk about it. They're so afraid of that model because it's not spooky enough. It's not magical enough somehow. It's too physical, too rudimentary, too fundamental, too crude. They want their universe to be fancy. They don't want to be doing something simple as pushing. They don't want to be the byproduct of a push. They want to be loved. Yeah. They don't want to think that they were forced into something. They want to think they were pulled into it. But yeah, it's just garbage. And this idea of a time dimension is just nonsense. Time is, the only way you ever see time function is just this fact that it takes a certain amount of time for a photon to cover a certain amount of distance. That's the most standard way we measure this thing called time. And there's no dimension of time. It's just a byproduct of movement. And there is no physical evidence of anything being dilated in our real world. Now, they speculate that because atoms change when they move a speed, that they degrade less quickly, that somehow that must mean they're in a new time dimension. And that's what's causing them to be dilated and slowed down. But the simple explanation is that they're just multitasking when they have velocity. They're doing more than one thing. They're not just standing somewhere doing, I'm an atom. They're doing, I'm an atom plus I'm an atom moving, which takes more time in terms of the function of the atom. It makes the orbits bigger. You could sort of understand that if I had a sun that didn't move in space, that the orbital time would be a certain speed for something around it. But if I start moving it against that orbit, you can sort of understand that whatever's orbiting around it would have to take bigger circles. And if it's moving the same speed, those bigger circles would take a longer time. And so it would look like it's been dilated because it's not going around. He's not hitting the 12 as often as it used to. Okay, but it's just the clock is broken. That's simple. So the simple answer to all of what we see as time dilation is just, no, the clock is broken. The thing that was measuring time has been altered and bent. And by bending it, it doesn't work the same way. That's simple. Not complicated. All right, so then they have something called electromagnetism, right? And there's these two fields that are so similar in their function. I mean, one's associated essentially with charge, and one's associated with magnetism. Now, they both do the same thing, which is attract and repel. And one does it in a kind of a dipole way, the magnet, and charge does it in kind of a monopole way, like it's either negatively charged or positively charged. So charge sort of duplicates the function of electrons and protons, where the magnet sort of duplicates the function of molecules that might have more electrons on one side and protons on the other side. And so they're polar. But it's all just one phenomenon. It's all just one force. It's a force interacting with two bits, the matter bits, the electron, the proton, the charge bits. And if you just understand that the force is also charged, that is, there's a plus force and a minus force, and they interact completely conversely, then you can understand why there's such a thing as attraction and repulsion. So when they're the same charge, they repel. When they're opposite charges, they attract. And you can perfectly explain why that happens when you just make two forces. It solves the problem. I mean, two pieces to electricity, plus and minus. Um, so, you know, it's perfectly rational explanation, perfectly within the scope of no UFOs, no magic, no entanglement, no ESP, no special sauce at all. Just a mechanical process that would explain how you can manifest attraction and repulsion by just making the force bits have the same property as the charge bits, the matter bits. So the force bits move the speed of light. They do all the transferring of momentum, and the matter bits segregate and react differently to one form or the other form in equal proportion. Let's see, are you going to take a live test exam for Lewin's lectures? Well, I don't even know what that means. What does that mean? These are exam papers, I think. I don't even know what that, why would I care? I'm not interested in getting a degree. I'm interested in understanding physics. And I'm pointing out these people teaching it don't really understand physics. Okay, they understand math, but they don't understand what causes are. They know how to describe effects. Describing effects is not being a great detective. Okay, showing up at the crime scene saying, yeah, that guy's really dead. And he's exactly 15 inches from the wall. And, you know, he's wearing a blue shirt, mostly blue, except for the red stuff on it. You know, describing the crime scene is not being a detective. All right. Okay, you know, because you understand everything so well from the lectures. Again, this is just what is this? I've already complained that the lectures are mostly math. I wish you'd do more experiments, and I wish the experiments you would do in a variable way. That's the whole big, huge controversy over his stupid inductor experiment. This demonstrates. One guy shows how, look, if you change the experiment, you change the values. Lewin's afraid to touch the experiment. He's afraid to change anything because he knows that if he changes something, his theory is in the toilet. You're just demonstrating more crap, Valerie. Let's see, you know, because, let's see, or at least HW papers. I don't know what HW papers are. Why do I care about any of this nonsense? Well, what's your claim here, bozo? You claim to understand what they say. No, I claim to understand better than them. I claim that their spooky space is nonsense. I claim that their idiotic wave theory of a two-slit experiment is absolute nonsense. That it doesn't even, their math doesn't even match the pattern on the wall. They say that there should be a 90% degrade in each one of those little lines, bars you see. They say it should be 80% less light in each bar. Is it anywhere close to that when those 40 bars are showing? Not even close. The math doesn't even match the pattern. Yes, if you wrap the probes around the magnetic coil, the probes will be affected by the coil. Well, so you're just demonstrating that Professor Lewin obviously isn't a very credible source of knowledge then, aren't you? Because that's not what he thinks. He thinks there's two voltages in the same location, dumbass. If you look at an intensity profile of the pattern, this is just nonsense. Sorry, I'm just saying it's quite obvious what the pattern's doing. There's quite obviously, when there's 40 bars of light, when you do the experiment and create the most bars you can, right, at the right distance, there's absolutely no possibility that each bar is 80% less light than the next bar. It's impossible. But just keep pretending, okay? Keep pretending your Eddington experiment was valid. Keep pretending all of these nonsensical, idiotic notions. Keep pretending that you can convert mass into bent space, even though Einstein never said any such thing was possible. Keep pretending that this dark matter, fake, phony, entangled nonsense world of their quantum qubits, their fucking fantasy stories have something to do with reality, when they have nothing to do with anything but somebody seeing a little bit of fur sticking out from the side of a tree, and they go yelling Sasquatch, Sasquatch, Sasquatch. They're just horny to find fucking unicorns, and that's what they're looking for is unicorns. It doesn't have anything to do with the truth. Believe whatever the fuck you want, but I just don't need this stupid whatever this crap is that somehow I'm doing thinking wrong. No, I'm doing thinking the correct way. I've looked at the evidence. I've done the some experiments on my own porch. I just don't need your critique unless you can actually critique something I've said, which you're not doing. Fuck. Incredible dumbasses. Anyway, back to my business. So then, redshift. So again, this wasn't something I had to think too hard on, right? So they noticed that things far away are redshifted more than things close. And so they conclude that, all right, the whole universe must be expanding at this certain rate to justify all this redshift and blah, 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 blah. And they just don't really say, well, let's think about it for 10 more minutes. 10 more minutes. Let's give it 10 more minutes of thought. See if we can come up with some other possible explanation. So then you kind of think, well, maybe photons get tired. Well, no, that doesn't really make any sense because there's no evidence they're getting tired, and tired wouldn't mean that means they'd all slow down, so there would be still the same frequency. It's not like they would get a different frequency from just getting tired. That can't work. And then maybe you could think, well, maybe there's stuff in the universe between me and something 10 billion light years away. Maybe there's some little atoms and stuff. And, well, yeah, that seems reasonable. Well, what kind of atoms would there likely be? Well, most of them would be hydrogen because that's the most abundant thing in the universe. And then helium second. Those are both transparent gases. And oxygen third. Lots of things. Well, not third, but anyway. But they'd be transparent atoms. Substances that are transparent. So if you hit an atom of that stuff, just like in our atmosphere, those atoms are transparent. That's why we can see. And so that's why I can see the camera and I can see the screen. It's because the oxygen and the nitrogen and the and all the stuff in the atmosphere they're transparent molecules. They're transparent atoms. So whatever photons hit them, they go right through them. They transmit through them. And so, but what if, as a little photon is traveling through space, going all this distance, it hits some of those atoms? Well, which way would those atoms be going more likely? Well, they couldn't possibly be going the same direction because they could never catch up to a photon. So the probability is if they're moving those little atoms, they're moving against the photon. And so then when the photon hits that atom, it's going to be transmitted, which means it's going to go in. And by the time the second bit of the photon goes in, there's more than one bit to the photon. By the time the second one goes in, it's in a different position. It's behind where it was before. And so it's actually stretching the frequency, which would be redshift. Wow, well, that's a perfectly rational explanation. Why don't people go for that? That's not what's meant by tired. Well, it doesn't matter. I was using my definition of it. It doesn't matter. I was just saying if you thought about it for 10 or 20 minutes, these are the kind of things you would think about. Well, what could possibly happen to a photon on its trip 10 billion light years? On that trip, that would cause it to be redshifted and explain, that would be a better explanation than saying every piece of the universe is flying away from every other piece. So we want a better explanation than that wacky one. And so we're just saying, what else could be the possible explanation? I'm just saying, and you give it a little bit of thought. That's all I did. I gave it a little bit of thought, right? I said, okay, let's think about it. And yeah, I thought about the fact that, well, wait a minute. The odds of a photon going all the way from the furthest away galaxy, 13 billion light years away, coming all the way through space without hitting anything at all, well, that seems pretty improbable. I mean, yes, there isn't many big things in the way, but there's got to be lots of little things in the way. And it's got to hit some of them. And what would be the consequence of hitting some of them? And the consequence would be it might redshift them. And that's a perfectly rational explanation, in my opinion. So it fits the evidence. It explains why things far away are redshifted. because they're redshifted because they hit atoms. And when they hit the atoms are going against their motion, not with their motion, by probability. They're more likely to hit an atom that's going against their motion than to hit an atom that's going with their motion. So they're automatically, okay, going to tend to redshift. So anyway, perfectly viable explanation. No funny expansion crap required. And what did it take? A little bit of thought, a little bit of detective work. Instead of just analyzing what exists, spend a little bit of time deducing how what exists could possibly be created. And don't jump to the first obvious conclusion. You know, don't say just because there's a knife and it has, I don't know, there's a broken fingernail next to it, you know, a painted fingernail. You just don't draw the obvious conclusion like, oh yeah, it must be the ex-wife or something. You know, it's evidence, but you don't jump. You don't jump the crime scene. You wait and you look for the rest of the evidence. And then you find that, oh, size 14 Bruno Malis. You start finding the other evidence that indicates, oh no, that fingernail's a dodge. That's a, you know, the criminal was clever. He threw that there just to fuck you up. You know, he's a smart criminal. Anyway. All right, so variable gravity is an interesting subject, but that's not really on this subject. But I'll throw, since I mentioned it, I'll throw it in. Just the idea that the whole universe in its conversational. Conversational. I can't say it any different. Conservational manner that, you know, is in fact that gravity does change. That as the matter condenses, as everything pressurizes, that removes pressure from the field. So the little bits, the little photons, get consumed holding the atoms together, and so they're no longer pushing as much. And then when there's this midpoint you get to, this, you know, you have an equilibrium, and then the pendulum swings one way, and then the pendulum swings the other way. So the universe gets loose, and then it gets tight, and it gets loose, and it gets tight. And that's why we see the difference. In the very old galaxies are very tight, very small, very, very, very intense, but very small. You know, thousands of times smaller than current galaxies. And that over time, they start expanding because there's not enough pressure to push them together. And then as they expand, they release a bunch of these photons and energy, and the energy goes back into the field, and then it starts compressing things again. The pressure gets greater on the outside and smashes everything small again. So it's just a process of expansion and contraction, not a bang, this expansion and contraction. Perfectly reasonable explanation, consistent with the evidence. All right. So this is sort of the big concept, is the idea that the north-south of the magnet is essentially the minus plus force emitter. And that's the same as the plus minus of charge. And that this really is just about two forms of energy, two types, okay? Because they're not as distinct as protons and electrons. Okay, I mean, protons and electrons have more than one difference. Not only is their charge difference, but they say their mass is different. But maybe it's not, because they really don't have a way of measuring mass. They really don't. So, of those tiny bits. There's no scale to put them on that isn't already charged and influencing their motion. So, you know, it's hard to do a pure measurement of their weight. But regardless, so there's two types. There's two types of force bit, plus and minus, red and black. Electron force, proton force. And there's two types of matter, you know, electron, proton. Positively charged, negatively charged. And that's all you need. That's the container of the basic elemental function. Everything else is a mixture of those things. So that's the element of the universe, is the force bits and the matter bits, and the fact that they are reciprocally charged. All right. So then you get into monopoles, and I sort of went into that before, but the electron and the proton are the magnetic monopoles. You can duplicate them in a sense, some of their features, by charging an object, like a little silver ball or something, positive or negative. To have any effect, it has to be a high voltage, a high pressure, for it to have a noticeable effect. And the higher that voltage, the more effect it has, the more repulsion it can create, or the more attraction it can create. So the amount of the force it's emanating, and the like things repel. So this is sort of where you get into the ping pong paddle argument. Electron, and you have black force. So it's black, it's negative, the force is negative, the other object is negative. It means the little negative force will just bounce back and forth between the two. You can understand, as a ping pong paddle, if I put them half closer together, I got twice as many impacts. That means twice as much force on both of them, just by moving them into proximity to each other. The closer I move them, I keep multiplying the amount of force because it reflects back and forth. And that's the nature of the effects of charge. That's the cause. Now, regular physics has no clue. They don't understand that at all. They have virtual photons, but they can't give them any character. So they don't really understand that, yes, the energy gets trapped right in between them. And so they think frequency has energy. But frequency only has energy because it means proximity. It means things are closer together, which means there's more reflections. And then more pressure outward. And the other inverse effect is, if this is a proton and an electron next to each other, then the feature of the electron is that if red force hits it, plus force, it goes out perpendicularly, leaves. And if black force, electron force, hits a proton, it goes out perpendicularly. So between electrons and protons, no force can exist. No force can reflect back and forth. So you can't magnify the force by bringing them together, because it all leaks out. And so they are attracted to each other because the external pressure remains the same, I, and the internal pressure reduces to nothing because everything leaks out. All right. A couple of new comments. With a fluctuating blast of concentrated energy. What could that mean? A deadly dose of shock surge through the enemy. I guess you want me to block you, okay? I get that's what you're asking me to do, right? Whew. Okay. You got it, buddy. Oh, man. Fucking idiots. Must be a foreigner. Yeah. Anyway, all right. So this is related to the idea of pressure, and that's the real game. Is low pressure, creating low pressure zones and high pressure zones, and that's all that really is. Either removing the force or magnifying the force by trapping it. So you trap force or you release force. And those are the things that create attraction and repulsion. And it's just changing that pressure. And the pressure has to do with the fact that, again, so this gets back to the atom and how the atom can be a monopole. That is, an atom can be charged. And it's charged based on how the proton versus the circumference of the electrons. So if I change the circumference of the electrons, I change how much exposure the proton has. So if you understand that the electron blocks the force from the proton, consumes it, it goes out perpendicularly, remember? You can understand that a proton doesn't have the same reveal if electrons are close to it, because then the electrons are essentially blocking most of its force. But if you have a certain distance, you change the distance of the electrons. So if you have an atom and you push some of the electrons down, you can sort of understand that that would change the profile of the proton, and it could make this now a give the proton less visibility, which would make it more of a electron reflective. You could also understand that if I compress it, these electrons are now closer to each other. So now if a black force is coming in, more of it will reflect back because more of it's going to hit electrons. So the atom, as it expands a little or as it contracts a little, changes from a positive to a negative ion, essentially. You don't need the extra electron or the absence of an electron, but it's the same thing. And so essentially what magnetism is doing to atoms is that in certain materials, it will compress those atoms. The atoms can't just move. They can't just do something to react to the force. They're actually physically compressed. And when they're physically compressed, they themselves become charged. And they will become, in a sense, express a form of magnetism. And fight back, so to speak, with the same force and cause either attraction or repulsion. All right. Force bit, matter bit. So again, that's just the basics. It's just this. That's all you need to understand is the force is the stuff moving the speed of light. It has a character in the sense that it has two properties, plus and minus. There's two forms of matter that are completely relevant, and that's the proton and the electron. The argument would be is neutrons are basically a proton and an electron. They're already a compound, and they help the proton stick together because the electron is serving as a conduit. So a neutron would be this, and if you put that next to another proton, another red thing, you could sort of understand that now these two red things could get very close together because all the red force leaks out of the electron. So the two protons can get very close together if you have an electron between them. It perfectly explains why the nucleus is so small and why you're able to put protons so close to each other. So it explains the strong nuclear force. And that actually it's not a strong force, it's an incredibly weak force. It's the absence of force. It's force leaking out. It's not, you didn't need a lot of force to push them together because you evacuated all the force between them. That's the key. So it's kind of ironic they call it the strong force when it's actually a very weak force. All right, then you have this wave-particle duality. Again, that's a spookily stupid compromise. Something just clearly easy to insult as a non-answer to the question. An obvious non-answer. Yes, no. That's all it's saying. Yes, no. Right, wrong. You know, it's retarded. It's not an answer. The truth isn't that there's any duality. It's one thing. There's one real description. And this is just a gross, weak compromise. And I would say notionally, it's a compromise that shouldn't even be indulged because the evidence of waveness is so weak compared to the evidence for quantized energy, particles, a quantized moving bit, moving the speed of light in a straight line direction. The evidence that photons are rays is way overwhelming compared to the evidence that photons are waves spreading. So it's just a duality shouldn't exist, and it all exists because of a subtle little coincidence that there's a similar thing that happens with waves in the sense that you can create an interference pattern that is the simplest pattern that's known. You can't make a pattern any simpler than on-off. It's as simple as it gets. And so it makes an on-off pattern waves. And the photons can make an on-off pattern when forced close to material. But all it is an angle. In the bottom line, the math demonstrates that it's just an angle in the end in the math. So all you're doing really is changing the angle. And we know that you can change the angle, the vector that the photon is flying, by scatter, by interfering with it in some way. And clearly the matter seems an obvious suspect for interfering. It has lots and lots of atoms with lots and lots of electrons. And clearly those electrons could be affecting which way the photons are going. You don't need any wave theory to explain the fact that there exists a pattern. We see it in light diffraction. We see it in optics, internal reflections. No wave theory really explains that. It's clearly an angular movement of the photon. Rainbows, wave theory doesn't do you much good when you start talking about a photon hitting a water droplet. Wave theory just makes a mess. All right. Entanglement. Just no evidence, no hard evidence for any of this crap. They have to contrive bizarre experiments where there's a little subtle difference in the probabilistic outcome to find some way to say there's some sort of correlation. That, but there's no way to prove this idea that there wasn't from the very beginning a right-hand photon and a left-hand photon created by an event. But there's no evidence that these photons are created at the same instant. There's no evidence of all the stuff they think that are part of this that they're measuring. And all of these entanglement experiments almost exclusively involve using a function like light polarization to attempt to detect these differences. And they don't even know how that happens. They don't even know how polarization functions. And yet they're using it as a test instrument. And so if it's true that polarization doesn't create 50-50 outcomes, then all the entanglement experiments are rubbish, essentially. They don't mean anything if it's not true that there should be a 50-50 correlation. And as I've explained with just simple logic, that if you understand polarization to be something like a bunch of jail bars, and you're throwing frisbees through the jail bars, you know that every single frisbee you throw horizontally won't get through. And you think that, oh yeah, if I throw it this way, it will get through, vertically. But the truth is, some percentage of the ones you throw the right way will hit the bar, and they won't go through. So it's not 50-50. So your intuition tells you it's a 50-50 filter, but the bars really aren't a 50-50 filter. They block 100% of this, and they still block, 4% of this. Maybe the waves are math. I'm sorry, I'm just saying that the math has a sine theta in it. It's an angle. They contrive the creation of the wave and do a whole set of geometry, algebra, to get the wave to turn into a sine theta angle. But what's in the math is an angle, not a wave. It's a vector, not a wave. All right. Yeah. I don't know, whatever. People are just so belligerently fanatic. You just won't let go. No, our crap has to be true. No, it doesn't have to be. All right. Light polarization. So that's sort of another subject, is what causes polarization. So again, as I pointed out, they have no explanation. They don't know what polarization is. So if you thought about it for a while, but you have to think about it in terms of a more logical explanation for what a photon is. But if a photon was just cannonballs or bullets, you could understand that when I shot, let's say if I'm shooting bullets somewhere, that I intend to shoot 5 bullets right at the bullseye. But the fact is, my gun twitches a little when I'm shooting. And so, one's a little above and one's a little below and one's a little to the right, and one's a little, so they're wobbling a little bit. That could be understood as polarization. That polarization is essentially, they're not quite lined up, the bullets in space. So they're coming at you with a little bit of this. And obviously the longer the wavelength gets, the more that little bit of difference adds up. to a bigger difference. So that would be perfectly tight wavelengths, it'd be just a little jitter. Longer wavelengths, more jitter. So the longer the wavelength, the more they're unaligned. By just logic, you can sort of just understand that if I fired it with the same amount of jitter, a longer distance of time, the jitter adds up, you know, because this travels at that different angle. So there's a slight different angle. And the longer the distance is, the more that angle matters. So the further away things get, the more the longer the distance between the individual elements. So anyway, it's a perfectly rational explanation for why there's a difference. That the atoms have Brownian motion, they are moving. They're likely moving in some sort of standard way, you know, this way, this way, this way, kind of jittering back and forth-ish. That would be the most obvious harmonic. There's no obvious harmonic that would be this, you know, complex. No, the harmonics would be obvious. Back and forth would be the most common jitter. Would be a back and forth motion. And so obviously if they were emitting a photon and they had a little bit of back and forth motion, you can understand they would emit their photons a little bit with a little bit of distance and at a specific alignment. So the 5 bullets would all be just up and down. One a little above, one a little below, one right in the middle, one a little above, one a little below, one in the middle, that kind of thing. So a perfectly lucid, reasonable explanation for what polarization is. Okay, no, they have nothing. I'm giving you something. And in my opinion, giving you something that's a little hard to say, that can't be true. It sort of does fit what we see. All of the filters do look like a bunch of bars. It does sort of look like the idea of throwing frisbees. It has every appearance of being something like that. So, all right, so no electromagneto stuff. No electro versus magneto. Okay, just monopoles or dipoles. So yeah, there's no electromagnetic fields. There's one field, and you can sort of see this in Maxwell's equations. Because the joke is they had 2 stupid constants they threw in to Maxwell's equations: the permittivity of space and the other one's like epsilon 0 or something. So you have something 0 and epsilon 0. These 2 silly constants, and those constants end up equaling the speed of light, 1 over the speed of light, or the speed of light over, yeah, 1 over the speed of light. Well, anyway, and the funny part is they want to, you know, as the Wikipedia page says, they'd like to rename those constants instead of the permittivity of space, the magnetic and the electric constant. Okay, so their 2 fields have a constant in them. Essentially, they're saying, look, in our math, it works to have these 2 constants, and the 2 constants are sort of established as 2 fields, and the 2 fields equal really the 1 field that is a photon speed. So you can sort of get the idea that, yes, these 2 fields are superfluous. There's only 1 field. That's defined by the speed of light. There is no half the speed of light here and half the speed of light here. There's no electric field and magnetic field. There's 1 field of energy, 1 type, plus and minus. There's 1 thing, charge. And there's only 2 ways to express charge: as single monopoles, separated things, an electron over here, a proton over here. That's 1 form of charge. Okay, individual monopoles, separated by where they're not affecting each other, distance. And then there's charge, where the 2 are tied to each other, and that's a dipole. So the field created by a dipole obviously is very different than the field created by a monopole, in the sense that the dipole doesn't have any field here in the middle. It has 2 distinct ends that create pure force and then mixed force from the side, and clearly an ability to be polarized. That is, have a positive end or negative end that must align. If 2 magnets come into each other, the same poles, they'll repel each other. opposite poles, they'll attract each other. So the magnetic field and electric field are just a nuance of monopoles versus dipoles. It doesn't have anything to do with being two separate fields. The photon is not waving in the electric field and then waving in the magnetic field. None of that crap is necessary. There's just one field. It's either being flooded by monopole forces or it's been flooded by dipole force. Created by. Monopoles are created by dipoles. All right. Charge is usually high voltage, so I already mentioned that, but that's why charge is so, like, it works at 2 feet away. It's because it's a very thin layer of magnetism, but it's a very pure amount of magnetism in that it reflects everything almost. It's 90-10 or 99-1 in terms of how pure the reflection is. You're almost guaranteed that if an electron force hits a negatively charged object, that it will reflect. There's like a 90% chance. It's so black. It's so reflective. It's such a mirror to that force. So charge is usually expressed in things that are very reflective in terms of their monopole character. And so that's why they appear to have more strength, but they really don't. They're just pure forms because they're not polluted by being dipoles. The red isn't getting mixed in. The red and black isn't mixing. So it's either pure red or pure black. All right. No real reflection. So this is kind of important. So yeah, we see reflection. We see it all the time. Stuff reflects, and I could bounce a ball off a surface, and I could say I can just say it bounced off. But it's always more complicated than that. Even in our big physics world, there's energy that transfers into the thing. The pressure changes. The atoms are crushed. Sound is created. All kinds of things happen. And in atoms, when they're exchanging this force, when they're absorbing force, photons. So no photon purely ever reflects off anything. It's always absorbed. And the only question is how quickly it is re-released. So in a sense, the electron always absorbs the photon. It always moves a little. And the question is will it release the photon in a millisecond, a trillisecond, a billionth of a second, or 10 days later, or 50 years later? And that's the only thing that changes, is when does this electron stop moving and give the photon back? So everything is a reflection, and all reflections are first absorptions and readmissions. So all reflections are readmissions. There's no such thing ever as a photon bouncing off of something. It always has to be consumed and then readmitted. So there needs to be an equal but opposite force has to interact with the object and force the photon back. So the reflection only happens because there's an equal and opposite reaction that forces the electron to give the photon back. And that's a reflection. All right. Let's see. Force density is, man, my eyes, is caused by movement. Yeah, so that's just the argument that as you bring things closer together, you're just creating more density and more you're making the mirror like increasing the pressure. The higher the pressure, the more pure the mirror, the more reflective it is, the higher the density of the probability of reflection, immediate reflection, absorption and readmission immediately. So yeah, I don't know what else to say. I don't know exactly why I thought that was important, but it's on my list, so it must have some meaning. So anyway, that's the list for now. So if there was some subject you think I missed, I think that covers all the subjects that really matter, but there might be some I forgot about. all the aspects or features. I'd say there's no spin, so I should write down spin and just account for it as more of the entanglement mush. Spin is not an important feature. It's certainly not in the form of spin. It's in another form. Well, I won't say that exactly. Spin is this idea that you can collect energy by spinning. Okay, so and especially in space, you can understand if you have something spinning in space, let's just say it's rotating relatively slowly, and I add energy from any direction. The idea is it's going to, anywhere but on the center of its gravity, it's going to add to the spin. So it's going to spin up the object, but also move the object in the direction of the spin. So obviously it retains the angular momentum, so to speak, of whatever's the photon, let's say in this case. Its angular momentum, the fact that it came in this way, is going to be remembered by the thing spinning, because the thing spinning will actually be moving in that combined direction of that added bit of momentum. So there is a memory for where the energy came in. So then there's an idea that eventually that energy can come back out. There will be an equal and opposite reaction eventually, because this thing is moving and it's going to hit something eventually and give back that element of energy in exactly the same direction. So there's a conservation of angular momentum. But I just don't think electrons need it, protons need it. I don't think any of the elemental bits are relying on spin. They could be. The electron could be spinning and it could be absorbing. That's how it's absorbing the photon, is it absorbs it as spin. But I don't think that's what it's doing. I mean, I just don't think it's a propeller that you push. I don't think that has anything to do with it. So anyway, but clearly it's a function in the sense that the idea of absorbing energy at angles, different directions. So a thing absorbs energy at different directions, gets hit by stuff at different directions, like the Earth going around the sun. It's being hit by force from different directions. And the net movement is a consequence of if you add up all the forces, what are the forces doing? They're pushing it more this way than that way. That's why it's moving. So you can use spin to model that function, but it's a model of the function. The absorption actually could be just in some other form. It doesn't require there to be spin for you to absorb that motion, but spin could be used as a model. So I'm not saying, so I'm not saying their idea of spin is wrong. I'm just saying whatever their conception of it, I don't think they're appreciating the fact that you're absorbing the energy to have the spin. The spin isn't independent of you having to absorb something that's actually moving. That is, you have to absorb force to spin. You don't have spin unless you absorb force to acquire the spin. That would be my argument. The spin isn't native. The spin is a byproduct of your history. Yeah. So, see if there's anything else. Yeah, no, that's all it's on the list. So I added a new thing to the list. So at least we got one new thing, spin. So I think I covered everything. Everything's on the list. Like I say, if you have some other thing you can think of, then fine. I would appreciate it. Some other fundamental aspect of physics that needs to be accounted for. But I think I covered them all. So, yeah, I guess I could have had a better graphic all this time. Yeah, showing the Dopey comment page. It's kind of boring. Oh, my hair is kind of weird. What else is new? No surprise there, Gary. Yeah, nothing. It's really so little going on. Nothing very important. Professor Lewin asked I think, a pretty simple question. one of his problem, whatever, I guess, is distraction from the controversies. Now he's just going to pretend it never happened, which is fine, but I just mean it's just kind of obvious. So the question's just an inverse law question, so half the distance, twice the effect. So, obviously the answer would be 4. Pretty sure. 4 is the answer. 4 times less force. Yeah, there really isn't anything else going on. Disappointing. The physics world is quite boring. Except for me. I am incredibly interesting by comparison to the rest of the physicists. Yes, seems the obvious truth. So I guess that'll be it if no one has anything to contribute. And again, I'll work on, like I said, I hate to give up on this. It's nice to have these, this form of video and everything for live rooms, but it really does do such a hatchet job on the frame rate that I have to find a different solution and such. So maybe I can make my full screen, use the full screen and just try to put the windows in the right location or something, the desktop or something like that. We'll try that. That was the old style of doing it. That worked better than this. So we'll probably do that. This was convenient, but it just doesn't work. Any user comments you could debate? Yeah, well, I already looked at it. You saw the comment section. There's just nothing there. So I already did the one new comment, so nobody's saying anything. So very little to debate with. Yeah. Nobody can form an argument without being insanely rude. So, it's just no point. Because I could read comments on somebody else's video. I guess I'll have to resort to that. So that might be a thing to do next time. Pick a good video on a specific controversial subject and see how much reasonable commenting there is. And such. But I do like to keep things specific to my theory, my challenge to conventional physics. I mean, that's more fruitful. Yeah, well, it wasn't much of a comment, so I'm just saying you didn't miss much because the comment was so it was just a personal attack. There really wasn't any, really wasn't any comment in the comment beyond insulting me. Let's see. They take everything at absurdium. They take everything at its absurdium. Yeah, well, I mean, it just seems like everybody is just fanatic. They just have no ability to see. Like I said, I'm not a great fan of compromises. I'm not a great fan of seeing both sides or any of that much. But clearly, these, like I said, there's insanity on the left of me and insanity on the right of me. I mean, they both seem like insane positions. And there's just no other way to describe them. They both look like cartoon characters. And you're just saying, this can't be the truth. I mean, Jimmy the Cricket is not the truth. And fairy godmothers aren't the truth. I mean, this is, Godzilla isn't the truth versus, some other happy lizard. It's just not reality. And everybody just seems so full of shit and yet so arrogant. I mean, they're so dumb. Their positions are so weakly evidenced, and yet they're so certain they're right. It just doesn't make any sense. How can you be that certain you're right when your argument is so weak and your evidence is so weak? I don't get how people can do that. I mean, I'm confident. I'm arrogant. But frankly, I've earned it. in the sense that I've done enough of the fiddling around with this thing, looking for the counter arguments and being prepared to argue it. I'm prepared to defend my theory. They are totally inequipped to defend anything beyond just saying, I'm right, you're wrong. I mean, they can't defend the evidence. They can't, they just can't, and so they just walk away saying, I'm right. And, that's just a nothing argument. Horribly nothing. All right. So anyway, until the next time and such and so forth and whatnot. Thanks for your participation. And last couple of videos have been pretty good, I think. Got some good stuff done, I think, in these conversations. Whether, it didn't help much people, but I did my part of the job. Anyway, till next time.